This is the review for your test on fraction operations. Mason made some food for a sleepover party. He made chicken sandwiches and meatball sandwiches. He also made chocolate cookies and sugar cookies. Which list below shows all of the possible outcomes if a person randomly picked one sandwich and one cookie? So this type of problem involves sample spaces. We started the probability portion of our unit on sample spaces because in order to calculate or determine what the probability is, you need to understand all of the possible outcomes. And so if a person could pick one sandwich and one cookie, they have a choice of chicken sandwich or meatball sandwich. And if the person chose a chicken sandwich, they could choose either a chocolate cookie or a sugar cookie. If they chose a meatball sandwich, they could still choose either a chocolate cookie or a sugar cookie. So the sample space of all possible outcomes would be chicken, chocolate, chicken sugar, meatball with a chocolate cookie, or a meatball sandwich with a sugar cookie. When you look at the answer choices, clearly choice A doesn't work because there are only two possible outcomes there. In fact, you could eliminate A and C because answer choice C has 6 possible outcomes. We know there are a total of 4 possible outcomes. Chicken chocolate, that's my first one. Meatball chocolate, that's down here. Chicken sugar, meatball sugar. So it looks like answer choice B. Let's make sure we can see what's wrong with answer choice D though. Chicken sandwich and a sugar cookie, we had that as one of our possible outcomes. Meatball sandwich and a sugar cookie, that was another possible outcome. Chicken sandwich and meatball sandwich, that wasn't one of the way the choices were described. You were choosing a sandwich and a cookie, so that doesn't work, and neither does 2 cookies. So answer choice B. We could also have taken the number of choices of sandwiches 2, the number of choices of cookies 2, multiplied them together and realized there are 4 possible outcomes. That's the fundamental counting principle that we discussed, and so that could have eliminated answer choices A and C. Problem B is a quantitative comparison problem. We're comparing the reciprocal of 3/38 to 2 to the 3rd power. The reciprocal of 3/38 is 38 thirds, and 2 to the 3rd means 2 multiplied by 2 multiplied by 2, which is 4 times 2 or 8. So I know the quantity here is 8, and I know this quantity is 38 thirds. Still not really easy to compare them though, because one is expressed as a fraction and one is expressed as a whole number. You could go 2 ways with this. You could express 8 wholes as thirds. I know each whole is 3 thirds, so if I have 8 3/3, that's 24 thirds. And then I would see that A is greater than B because 38 thirds is greater than 24 thirds. We could also have made 38 thirds into a mixed number by finding how many 3's are in 38. There are 12 because 12 times 3 is 36. And we would have 2 thirds left over. So this is 12 and 2 thirds, which is greater than 8 wholes. Problem 3, we're finding the quotient. We're dividing mixed numbers. So we need to convert these mixed numbers to improper fractions first. 9 times 2 is 18, plus 8 is 26, so I have 26 ninths divided by 3 times 4 is 12, plus 1 is 13 thirds. And you may have learned keep, change. In previous years, I prefer to talk about the definition of division. Dividing is the same as multiplying by the reciprocal. So 26 ninths divided by 13 thirds is the same as 26 ninths multiplied by the reciprocal of 13 thirds, which is 3/13. Now the product of the numerators tells me how many pieces I have. The product of the denominators tells me the size of those pieces. But before I start multiplying, I want to see if there's any way to simplify. 3/13 is simplified. 26 and 9 don't have any common factors. However, I can look this way. 26 and 13 have a common factor of 13. So I could divide them both by 13. 13 divided by 13 is 1. 26 divided by 13 is 2. And what I've done by doing that is I've factored out 13/13, which is 1 whole. And we know from the multiplicative identity that we can factor out 1 whole without changing the identity of this expression. 3 and 9 also have a common factor of 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So now when we multiply, 2 multiplied by 1 is 2. 3 multiplied by 1 is 3. And so our quotient here is 2/3. Problem 4. The maximum weight for a basketball is 22 9/10 ounces. For a baseball, it is 5.5 ounces. And for a tennis ball, it is 2 1/16 ounces. How much heavier is a maximum weight basketball than maximum weight baseball? So we don't care about the tennis ball. We want to know the difference between the basketball and the baseball. So 22 9/10 minus 5 1/2. I can't subtract halves from tenths. They're different size pieces. So I'm going to rewrite this as 22 9/10 minus 5 5/10. Because 1/2 can become tenths if we multiply by fifths to get tenths. So I need all 5/5 so I don't change the identity. I don't change the value of the 1/2. Now I can subtract. I can subtract 5/10 from 9/10. I get a difference of 4/10. And I can subtract 5 wholes from 22 wholes. They're like terms. I get 17 wholes. 4/10 can be simplified. There's a common factor of 2 there. 4 divided by 2 is 2. 10 divided by 2 is 5. So our final answer is 17 2/5 ounces. Okay, that completes page 1.